Hello everyone. Welcome to the first episode in the Revernos Machine Learning playlist. In today's video, we will be giving you a complete and thorough overview of the KNearest neighbors machine learning algorithm. Here's a quick overview of today's agenda. We'll start by describing what is KNN. Remember, KNN is short for KNearest neighbors. We'll then tell you how does KNN work. We'll show you how you can implement a KNN in Python for both classification and regression problems. We'll dive into some of the pros and cons of the KNN model. We'll give you some tips and tricks for how to improve your KNN model. And then we'll discuss when you should use this model. And then we'll give you some next steps at the very end. So let's dive right into talking about what is a KNN machine learning algorithm. K-nearest neighbors is a supervised machine learning algorithm. Remember, a supervised machine learning algorithm is a machine learning algorithm that requires you to have labeled data. It is a classification algorithm that can be used for binary or multi-class classification problems. It can also be used for regression, and we'll talk more about that later. It is a simple machine learning algorithm that is both supervised and non-parametric. Non-parametric means it does not have parameters, but that doesn't mean you can't change certain things about the model, and we'll touch more on that when we get to the how can you improve the KNN model section. The algorithm is so simple because it only consists of the training data set. That adds to the simplicity of the model, but that can also bring some drawbacks, which we'll talk about in the pros and cons section. So how does KNN work? KNN works by taking in the entire training data set. When a new value from the testing data set is brought into the model for a prediction, the model will calculate the distance between the new data point and every point in the training data set. The model will then find the nearest neighbor to the new data point and classify the unknown data point as the same class as the nearest data point in the training set. The K in KNN refers to the number of data points used to classify new data points from the testing data set. For example, if K is set to 1, then when a new data point is brought in, the model will find the one nearest neighbor and use that to classify. If K is set to 2, then it will use the two nearest neighbors and use that to classify. How should you find the right value for K? You should run multiple models with different Ks and see which one gives you the highest accuracy. The picture below shows a graph that contains length and weight. Let's say these are the lengths and weight of two different dog breeds. On the left you can see we have some dogs that are long but not heavy. Let's say these are dachshunds or wiener dogs. Let's say the dogs on the right, they are heavy but they're not long. We can say these are bulldogs. This is obviously fictitious data and a fictitious example, but we can graph our training data set here so we can see how our data looks and we can see how many classes we might have, which might give you some sort of early estimate for what you should use for K. So here we have our training data in black, and the red question mark is a data point from our testing data that we need to classify. So let's say K is set to 1. So what the algorithm will do is it will calculate the distance from our red point to all of the black points, which are the points in our training data set, and then it will pick the one nearest neighbor, and whatever the class of that one nearest neighbor is, so whether it's a bulldog or a dachshund, that is how we'll classify that red data point. So let's see what this looks like in practice. So here you can see we have a yellow line connecting our unknown instance from our testing data to a known instance in our training data. And we draw this line because this is the shortest distance between our unknown point and our known point. And so we will label the unknown point as the class of this known point, which would be a dachshund. Also, note down here it says testing data in black. That's a typo. That should say testing data is in red. For the remainder of the video, the testing points will be red and our training data will be in black. When we say calculate the distance between 2 points, it's important to know exactly how we're doing that and which method we're using. In reality, there's a lot of different ways you can calculate the distance between 2 points, but the most popular one by far is Euclidean distance, which calculates the distance between data points using the sum of their squared difference, which you can see in the formula here. Manhattan distance is probably the second most popular, and it uses the sum of the absolute difference of the data points. And Manhattan distance is also sometimes referred to as city block distance. If you're unsure which method you should use, most of the time you'll start with Euclidean because that's the most popular, but you can also experiment with some other ones and see how that affects your accuracy, and then choose one with the highest accuracy. Earlier in the video, we talked about what happens when k equals 1 and we only use the one nearest neighbor to classify a new data point. Now, what if we use a different k? In this example, we have k set equal to 3. Now, this red question mark is an unknown instance from our testing data set, and we have to classify it. So when k is set equal to 3, we use the 3 nearest neighbors to label this instance. We have lines drawn from each of the 3 neighbors' nearest, and we can see 2 of them are the squares and 1 of them is the black X. Remember, the squares are dachshunds and the X's are bulldogs in our example. So of this example, we have 2 of the 3 nearest neighbors being dachshunds and 1 of the 3 nearest neighbors being a bulldog. And so we will label this instance as a dachshund because the majority of the nearest neighbors are from that class. Now we'll talk about what happens when we set k equals to 2, because this is an interesting case in our example. What happens when you have a case when k is equal to 2 and you end up with a tie? So one of the nearest neighbors is a bulldog and the other one is a dachshund. Well, in our example, in this particular example, let's assume that this red point is equal distance between both of these 2 points in our training data set. So what will happen if we have a tie? How do we break ties with KNN? And what we actually see is this is directly from the scikit-learn documentation, and it says, regarding the nearest neighbors algorithm, if it is found that 2 neighbors, neighbor k plus 1 and k, have identical distances but different labels, the results will depend on the ordering of the training data. So in this case, the ordering of your training data will actually determine what this is labeled as. So ideally, what you would want to do is prevent your KNN algorithm from having ties. So if you're doing a multi-class classification problem, you want your k to not be the same kind of number as your number of classes. What do I mean when I say that? I mean, if you have an odd number of classes, then you would want your k to be even and vice versa. And that way you won't have to worry about this situation where, let's say we have 2 classes and k is also equal to 2. And then that just enables the chance of having a tie. So if you have an odd number of classes, then you want your k to be even and vice versa to prevent this situation. Earlier in the video, we mentioned that KNN can also be used for regression. While KNN is usually a classification algorithm, it can be used for regression. In this case, the output label would not be a class, but instead it would be a numerical value. The model would find the distance between the training data points and the new data points from the testing set and calculate the distances. The k-nearest neighbors would be averaged into a predicted value for the new data points. This could be done using the mean and median, and which one you choose between those two, you should run your model with both and see which has the higher accuracy. So let's go back to our k equals 3 example from earlier. We wouldn't have class labels for these 3 data points, we would have numerical values for them. And what we choose to classify this unknown data point as would be the average of the 3 nearest neighbors in this case. Now we're going to start coding in some Python so I can show you how you can actually implement a KNN algorithm in Python using sklearn. So you can see up here I have a lot of import statements, and I'll briefly explain what each of these is. So from sklearn datasets, we are importing load breast cancer, which will allow us to use a breast cancer dataset, which is one of sklearn's default datasets that comes with the package. From sklearn model selection, we'll import train test split, which is exactly what it sounds like. It would allow us to split our data into training and testing data. Then lastly, from sklearn.neighbors, we'll import the kneighbors classifier, which is used for classification, and kneighbors regressor, which is used for regression problems, because I'll be showing you how you can implement both of those. So the first thing we do is actually we need to access our data. So we'll call our data set cancer, and we'll call the load breast cancer function for that. Don't forget your parentheses on the end of that. Now let's see what type of object we have in our data. You can see it's a sklearn bunch object. So what we actually need to do is access the data from this bunch object. Before we do that, let's do cancer, the type of cancer.data. And you can see now we have a NumPy n-dimensional array, which is something we can work with. And we also have the target, which we'll also need to build our algorithm. Okay, so let's go ahead and look at the shape of our data. So we'll do cancer.data.shape. You can see we have about 569 rows and 30 columns. So this data set isn't too large, so it will be a decent candidate to use a KNN on top of. So now let's actually go ahead and do our train test split. So we'll do X train. Sorry, make sure you spell train right. X test, Y train, and Y test equals train test split. We'll be splitting cancer.data. Then for Y, we'll be splitting cancer.target. And we'll set our random state equal, we'll just set that equal to 1 for now. Then go ahead and run that. Now that we have our training data and our testing data, we can now go ahead and actually build our algorithm, which remember, KNN is a non-parametric model, which also means it's a lot easier to implement in Python. So we can just go ahead and do KNN, which is what we'll call our model. Set that equal to K neighbors classifier. And then there's n neighbors, which is where you set the value of K. And we'll just set that to 1 for now. Then we'll run that. And now that we have our model, we need to essentially train it or fit our data to our model. So we'll do X train and Y train and run that. I need to add one more cell. Alright, so now once you fit your model, we can actually see how it does in terms of predictions. So we can do knn.score, and we'll do X test and Y test. You can see we're getting about 92% accuracy, which is very good. From here, there are several ways you can improve your model, which we'll talk about, but that's just the base of implementing KNN for classification in Python. So now let's look at how we can actually implement KNN for regression in Python. If you have the code for a KNearest classifier type, using the KNearest regressor is extremely simple. Literally all you have to do is change this word classifier to regressor, and then rerun that code, retrain your model, then use the score method to make your predictions. And you can see here our accuracy drops considerably, and that can happen. You know, when you go from a classification to a regression problem using the same data set, they're likely going to have very different accuracies, and that's fine. That's just part of machine learning. So let's talk about some of the pros and cons of the KNN model. Some of the pros are it can be easy to implement, as you just saw. It can be easy to understand and easy to visualize in the 2D space, so if you only have 2 independent variables. Some of the cons are because it uses the entire training set and has to calculate the distance to every single point and then choose the smallest ones, the smallest distances I mean. That can make your model slow, especially if you're dealing with a large multidimensional data set. And so this model does not perform well with a large number of features. There are some ways you can improve your KNN model. You can normalize your data. You can experiment with different values for K. You can also experiment with different distance calculation methods. So when should you use the KNN? If you have a small data set that doesn't have a lot of features or rows, or you need a model that needs to be explained easily, or you do use a KNN and the accuracy is acceptable, then those all make your situation a good candidate for a KNearest neighbors model. Thank you for watching. Please subscribe and click the notification bell so you don't miss an upload. We have a lot more machine learning content coming in the future, as well as content about cloud computing, web scraping, physical computing using Raspberry Pis, financial engineering, and many other topics. Don't forget to like this video and leave a comment letting us know what you would like to see in the future. Thanks for watching and see you in the next video.